So, hey guys, today let's talk about the vertex form of a quadratic equation, and this will be a transformation from the general form. So, the general form is usually ax squared plus bx plus c is equal to 0. Then, the vertex form is usually written as, let me make this y. This is y is equals to a into x minus h squared plus k. So I want to show you how this equation can be transformed into that equation, and I'll tell you what h and k actually mean. So you have to do something called completing the square. Completing the square. The trick will be you won't have to do it all the way, because when you do completing the square all the way, you will be solving for a quadratic equation. And if you're able to do it all the way, there's a video attached onto this, you can go look at it. You will be able to derive the quadratic formula. For this one too, you just need to understand a few things, because when you complete the square, there are a few steps you have to follow. So step one, you have to ensure the coefficient of x squared is 1. So for example, I have the equation x squared plus bx plus c is equal to 0. So that means because I have a starting, I'll have to find a way to get rid of it by dividing it all the way like that, all the way. So a will cancel out there. So I'll be left with x squared plus b all over a of x plus c all over a. Then step 2, we'll have to collect like terms. Collect x terms to the left hand side, and non x terms to the right hand side. Simply means because we have an equal sign here, you can simply move that way, so that you'll be left with these two guys carrying an x. So if we rewrite that, we're going to have x squared plus b all over a of x is equals to minus c all over a. Now, to complete the square is whatever we do in the third step. This is the most important thing. You will have to introduce a perfect square. A perfect square on both sides. So, first of all, what is a perfect square? A perfect square is a term that you can cram or anything. It's b over 2a, the whole thing, squared. It is the square of the coefficient of x. Now, you might ask me, why am I placing a 2a over here, yet there was no 2a over here? And I'll advise you, go into the link, watch how we complete the square, and you'll understand it better. So my equation reads x squared plus b all over a of x plus the perfect square. I want to use a different color there. So my perfect square is b all over 2a squared, and I have to add it on both sides, b all over 2a squared, like that. Now, once this is introduced, then this guy can be deleted. deleted, sorry, deleted, to delete. So this guy is gonna get deleted. I'm gonna be left with this guy and this guy alone. So I'm gonna have something like that is this way: x squared plus b all over 2a squared is equals to minus c over a plus b all over 2a squared. Now, this side is what I'm calling the left hand side, and this is what I'm calling the right hand side. So on this left hand side, we do something called we complement the square. What that simply means in maths, as I was taught by my teacher, is that you allow these two terms to be under the same square. So you put x plus b all over 2a under the same square. Now, this is equal to, now on the other side, the right hand side, what you will do, you will simplify. So you're going to have minus c over a plus b all over 2a squared. So we need to simplify this chunk real quick. So first of all, let's square this out. We're going to have minus c over a plus b squared all over 4a squared. And you can see by virtue of that, automatically, you can have something here that's the same LCM. So let's return this guy on this side plus b all over 2a squared. Now, whatever this equation represents, this chunk here is a constant, and you can bring this chunk back to this side so that your equation can read something like this: x plus b over 2a squared, then plus c over a. Now this will be minus b squared all over 4a squared. Now, it might look difficult, but this is, when you do the maths, this will be simplifiable. Like, you'll be able to simplify that version. And you can see a few things over here. Number one, you can see this term here that doesn't carry an x, and you can see now this term here. So if you look back into what we started with over here, we mentioned that the term that comes in here is h, and h also happens to be this point at the vertex here. If I was to locate this coordinate here at the vertex, that coordinate is coordinate this one. This coordinate is coordinate h, k, and you happen to have this line here, this one. That's your line of symmetry. This is your line of symmetry. And you can see the line of symmetry x is equals to what? To h. And where is h located in this equation? H is here. So whatever h is will always be this guy. So the negative of h will always be b all over 3a, which also happens to be x, which also happens to be the equation of line of symmetry. So that's the first coordinate that you need. Then you have coordinate k. This guy over here. You have k over here. So k is the other coordinate, the y coordinate of the vertex. That is the y equation. So you can think of that as k is equals to, now, the whole of this box over here, c over a minus b squared over 4a squared, and this is equals to what? This is equals to y. Now, the thing is, you have to do a real equation to see what this really means. So I'm going to attach a video to this. Please kindly watch the video that follows this one so that you can see an example, and I'll bring both concepts together. All right, catch you in the next video.